Okay, thank you everybody for joining in today. It's really good to see everybody here present today, given the current pandemic situation, right? Most of the things are now going virtual, right? So therefore, we have set up a few of this technology talks program to actually share some form of useful information for the students, right, and alumni of SHRDC, right, regarding what is the ongoing emerging trends of technology, right, and how we at SHRDC, the team here, the technical team, is really pushing forward in terms of delivering, programs that are related towards emerging technologies, right. So therefore, you will see that some of the topics here are not the usual topics that you will see out there, right. We try to come up with newer topics, like AI, data analytics, and I think we have one more session on the, digital factory simulation, right? So today we're going to talk a bit more about condition monitoring and how condition monitoring is used, right, to actually, monitor machine health, right? As we all know that, machine health monitoring is one of a very important aspect, right, in terms of smart factory technologies. So therefore now, we are moving towards how do we utilize, smart factory enabling technologies to do machine health monitoring. So a few areas that we'll cover here today. One would be, the data-driven strategies towards manufacturing and how it relates to cost optimization. Why is it important, right? And then we talk about machine health monitoring and how it is used to optimize equipment effectiveness. And what are the sort of machine health monitoring strategies that are there to support, these kind of applications? And at the end of the session today, there will be a quick pop quiz, right? Because as shared by Marissa just now, all that joined today have opportunity to win some cash vouchers, right? So therefore, the pop quiz is there to sort of allocate your marks, right? So make sure you put your real name, right? Not bubbles 1, 2, 3. And then, to get the marks, right? So make sure you put your real name and then you can get your scores. And then at the end of the day, you can, win some prizes. All right. So now Industry 4.0, as what many of us hear, many times, right, is talking about, the industrial revolution. But generally, what is the key importance of Industry 4.0 is all about how you utilize data to create useful information for you, right? So when we talk about the value creation of Industry 4.0, right, you start off with digitalization, right? We talk about computerization and connectivity, right? Without these two, generally, there's no Industry 4.0 that you can think about. Everything is all now digital driven, right? And then when you go into Industry 4.0, you talk about the how data is used to help you see, right? To give you insights, to know what is happening. And then how data is able to tell you why is it happening. And then, you talk about what will happen, where you talk about predictive analytics. And then talking about, self-optimization, right? Using the analytics data to actually adapt to the current situation, right? So using data to provide you with information and to forecast information that will give you that kind of valuable insight to create maximum value for you, right? So, and what data can do in terms of cost optimization, basically, when you talk about data, right, you want to know at the exact moment what is actually happening, right? The more data you have, the more information you have, the better the decision that you can make, right, with regards to the current issue that you actually have. So, for example, if your machine breaks down, right, do you want to know that your machine breaks down after 1 hour, or do you want to know that your machine breaks down, within 1 minute, right? That's how fast you can receive that information about your machine. Now, the next step of it is, of course, what are the form of analysis, right, that you can do for your machine? How do you speed up that analysis? How do you speed up the decision making? And how do you speed up the execution of the task, right, with regards to your machine, right? So every single decision that you make is time driven, right? What do I mean by time driven? Every day, we all have 24 hours a day, right? Nobody has more, nobody has less. If you have more, then maybe you can share with me some of your time, right? So everybody has a fixed 24 hours in the day. how do you make sure that your time is productive, right? So in manufacturing, every minute is cost to the manufacturer. So by optimizing your time, right, and minimizing all this time delay, or what we call as unproductive time, therefore you are actually able to maximize productivity and therefore reduce your cost of wastage, right? So machine health monitoring, what does it actually do, right? Now, let's say you assume that you have a machine that is running, okay? And when you run your machine at the start all the way until the end, right? Okay, let's give an example of your car. Let's say you're driving your car over a span of 100,000 kilometers, right? When do you know that your car actually has an issue? It's either you have an indicator, right? Or, maybe you hear some sounds or noises in your car, right? But you don't want to go to a point that your car suddenly has smoke coming out of your car. Then only you say, okay, now I need to bring my car to go and service, right? You want to be able to understand when your car is actually giving you a signal, right? To tell you that, okay, I need to be brought to the service center. I need to fix a certain part, right? So therefore, machine health monitoring takes into consideration, utilizing sensors information, right? To lengthen your P to F interval. So for example, if you look at this curve over here, right? The moment that you see smoke coming out of your machine or smoke coming out from your car, therefore you know that your car is going to break down anytime now, right? But if let's say you are able to detect at an early stage, right? There's another indicator that tells you, okay, my car is giving me some problem now, I need to bring it to the service center. Therefore, you actually have a longer duration to play before your car actually breaks down, right? So let's say if your car tells you, okay, there's a service signal coming out, there's something wrong with the motor, there's an imbalance happening, right? So when you measure vibration, you're able to tell at an early stage when you need to start to change certain parts. Therefore, you don't have to wait until a situation that your car immediately breaks down, to be able to send it to the service center. And, the longer that you wait for your car to go until it reaches the most critical failure, you will have other parts that will have a critical failure as well, and therefore your cost of repair will actually be very, very high, right? So therefore we talk about moving the P to F curve. P to F is actually potential failure to functional failure curve, right? So you want to ensure that you are able to actually detect at an early stage when the equipment is going to fail, right? So therefore you're actually able to put the right mitigation steps, and you prevent your machine from failing immediately, right? So you use condition monitoring techniques, right, to actually monitor and check the condition of the equipment and determine the rate of degradation over time. Rate of degradation means that over time your machine will have wear and tear, right? Every machine will have a wear and tear situation, right? So you want to know at which stage where you want to detect at an early stage that your machine is starting to wear, and therefore you want to change the parts at an early stage. So this is what we call as predictive maintenance strategy. So we are moving the maintenance strategy, right, using data analytics from reactive to preventive and all the way to predictive, right? So predictive maintenance will then be able to use data to actually forecast when you need to change certain parts of your machine. And you are able to change it based on the data that you get from your particular machine. So for example, right, for a car situation, do you actually really need to change your car oil and filters at 10,000 kilometers, right? Or can you actually go slightly further than that, right? Right now, it is all preventive maintenance because it is scheduled, right? 10,000 kilometers, go and change certain parts, right? But then it can be costly, right? Or some people, even before the 10,000 kilometer mark, they actually need to change it because the way they drive is actually not efficient, right? Let's say you drive in Kuala Lumpur or in certain areas where it's a high traffic jam, right? Therefore, you need to actually service your car more frequently compared to those that travel on a straight highway and has no jam at all, right? So predictive maintenance is to help you to actually predict when you need to do your maintenance strategy and which part actually is giving you the bad signals. So the 4 types of data analytics in more detail actually talks about descriptive, diagnostic, predictive, and prescriptive kind of maintenance strategy. So what we are trying to do is basically, descriptive analytics is to tell you what is happening in my business, right? Diagnostic is actually trying to tell you why is it happening, okay? And then predictive will talk about what's likely to happen, right? And then prescriptive will be what do I need to do, right? So all this basically will increase in complexity, right? But the value of information that you get will also increase over time, right? Because as you go into more complex prescriptive analytics, you're actually able to identify things a bit better and therefore gain more valuable insights and therefore able to make the right decisions better and faster. So an example of descriptive analytics, right, is about looking at the real-time status of a machine. So if you look at this chart over here, okay, if you are familiar with Google Translate, this is actually what you will see, right? Let's say you want to translate from English to Bahasa Malaysia, or you want to translate English to another language, right? You put in the English here and then you come out another language here, right? So right now, what we are doing is we are detecting the language of the motor. What the motor is trying to tell you, right, in signal form. Okay, so then it translates to, for example, what is happening to the motor? Something has happened, anomaly has detected, right? The motor has a problem, the machine will shut down in 15 minutes. So what it's basically trying to tell you here is, it's trying to tell you what is descriptive analytics, what is happening. Okay, something has happened to the motor. Why is it happening, right? Diagnostic. Okay, what is likely to happen? Predictive, which is machine will shut down in 15 minutes. Prescriptive will then be able to tell you what do you need to do next after it shut down, right? So therefore, this will then be able to give you real useful information of what is actually happening in a current machinery situation. Okay, so descriptive analytics can be as simple as using real-time OEE, right? OEE stands for overall equipment effectiveness, where we talk about availability, performance, and quality, right? A, P, and Q, availability, performance, and quality, which will give you your OEE, right? So therefore, in OEE, what happens here is that we talk about identifying root cause, right? Why is it happening? So from the three factor of availability, performance, and quality, you are straight away able to identify part of your 6 big losses. For example, your breakdowns, right, come from your availability. Your idling and minor stoppages and your speed comes from your performance metrics. And then your startup losses will come from your quality check. So all this already can identify your 6 big losses, right? Your root cause of why your A, P, and Q are actually lower than what is expected, right? So therefore, these are what we call as descriptive and diagnostic analytics. Then when you go into predictive analytics, you talk about what is likely to happen, right? So if you look at this system over here, you're actually monitoring a motor running, okay? You're actually monitoring a motor running. Now, in the actual look, it looks like nothing has happened to the motor, right? But as it goes over time, you start to see that there's a deviation in the signal that is being generated. That means you see that there is a difference, there's an error there, right? And that error actually will tell you that the motor is starting to fail, right? It is starting to fail. It hasn't failed yet, right? But the signals are drifting, right? And when the signals are drifting, you start to see that something is wrong with the motor already. And therefore, you need to do some form of, maintenance check to see what is happening to the motor. Why is it drifting off the chart of what is supposed to be, right? Because if you look at your whole motor chart, if you're actually doing the right analytic strategy, right, you're able to forecast your data, right, what is likely to happen in the next 1 hour, for example. And then if you start to see that your values start to drift, then you know that, something has really happened already and we need to check what is actually happening. So therefore, this is what predictive analytics can do to help you to move forward in terms of this data analytics strategy, right? But how do you get to this level? You need to have condition monitoring done first. Once you collect enough data, then only you can do your right analytics strategy. Okay, why? Because data over here is very, very important. We talk about this. We talk about the V's of data analytics, right? So, every machine learns from data, learns from information, right? The machine cannot learn without the information that you give, right? And therefore, for the machine to learn, they need to have what? Volume of data. That means the size of your data. Velocity, that means the speed of where your data is generated. That means you cannot collect data like, okay, today I collect, tomorrow I don't collect, next week only I collect another data. No, right? It needs to be a standardized velocity, right? It's a fixed speed of how your data is collected. Then you talk about variety, right? You don't just collect one set of data and then you say, okay, I know everything about the machine now, right? You need to have different varieties of the data. And therefore, from this data variety, you're then able to, get more information about the behavior of the machine for you to make the right analytic strategy. Then you talk about veracity. Veracity means accuracy of the data, right? You want to make sure that your data is accurate. You don't want to measure on the sensor is measured 39 degrees, but actually on your other measurement tool is actually 35 degrees. So then it's a big difference, right? So then you talk about value of the data, right? You need to collect data that is valuable for you and not just, for the sake of collecting data, right? It needs to create some value impact to your current application. So what are the key advantages of using condition monitoring for your production system, right? It helps to keep your machines running at optimum level, right? It helps you to reduce your overall downtime, giving you real-time machine health insight, reduce your overall maintenance costs, right? Improve machine utilization, improve your production output, and of course, giving you a more effective machine operation and a data-driven predictive analytics strategy. So these are all helping you to improve your current production system, right? So let's say if you go into the manufacturing industry, you go into the factory, you're then able to use data to make the right decisions for you, right? Not just saying that, oh, I think the machine is something wrong because I hear the sound a bit weird, right? No, it's all about using data to verify and to quantify what is the issue of your machines, right? Or your production system. Okay, so how do we then, generate this kind of data to do the right machine analytics, right? So in every machine that you go, right, in your manufacturing industry or in any place that you go, right, the types of data to be generated are usually either two types, right? One is analog, one is digital signal, right? So analog signal will give you what? Things like temperature. Temperature is an analog kind of signal. Digital signal is what? On or off, yes or no, right? So is the light on or is the light off? Is the part there or the part not there? Those are digital signals, right? If you need to measure things in weights or temperature or humidity, then those are analog signals to be considered. So these kind of signals can then quantify what you want to monitor in a particular machine. So you can have two ways of collecting data from machines. One, you can use like an IoT gateway. This is actually both technologies we have in the smart factory, right? One is the IoT gateway where you can pull digital or analog input, right? Another one is using what we call as IO-Link technologies, right? IO-Link technologies are considered smart sensor technology, where you can monitor both digital and analog input and give you that data information in real time, right? So from digital inputs or digital signals, right, a very, very straightforward application that you can do is directly translate those signals into your OEE metrics or your OEE dashboard. Therefore, you're then able to see the data running live, right? What is your availability happening now? What is your performance happening now? And what is your quality? So this will then actually give you more information and more insights on what is actually happening once you have this dashboard visualization tool that comes out from it, right? And of course, when you talk about condition monitoring for vibration analysis, right? Let's say if you put a sensor on a motor, this is using IO-Link technology, okay? You put a sensor on a motor and then straight away you are able to visualize what is the current vibration level of your machine, right? You are then able to tell what is actually happening in your current machine status. So once you on the motor, for example, over here, your motor starts to run and then straight away you start to see vibration data start to come in, right? So over time, right, when your motor runs, there are certain levels or conditions where your motor may fail, right? It may start to give you warning. So therefore, these kind of sensors are used to create that kind of visualization and to tell you what is actually happening in your current production system, right? So that when the time it has an issue, you are able to identify it at an early stage rather than wait for a very, very long time and then, only you identify what is the issue. So simple, dashboard analytics like this can be done using idling technologies, right? And nowadays technologies are very much, very straightforward to implement in terms of drag and drop tools like this. So this is basically what you will learn, in the Malaysian Smart Factory programs that we run, right? What are the type of technologies that you will be explored in this kind of system. So this is actually a demo set in our Smart Factory, right? I show you a video because we cannot really do live demos at the moment. But let's, come back again once the MCO situation gets better, okay? So in every single, data automation maturity, right? In every single kind of, application, right? We talk about maturity levels, right? A lot of companies, they always tell that, okay, I want to go into analytics, but they forget that the first step is actually collecting data, right? So the first step is actually collection of data. Then you visualize your data, you store, and then you formulate, right? You want to calculate what is your formulation matrix. And what you'll get after that is, you can run your data analytics strategy on it, right? So this one, I believe it will be covered tomorrow, right? Where one of our team members will talk about data analytics, right? And the day after, another team member will talk about AI, right? Which is actually part of our level 6, which we haven't included in yet at the moment, right? So these 5 levels of data maturity can then be put inside a production system like this, right? So from a production level, you will see that from a shop floor, you will see that you need gateways to collect data, right? So there are 2 methods of collecting data. One is from PLCs, one is from non-PLC method, right? Then you can store and visualize your data. And then you can formulate your data using OEE metrics. And then once you have all this information, push it to a data analytics platform, right? To do your predictive analytics. Okay. Now, as you are students, and as some of you are alumni, right, of SHRDC, what we always push for is the utilization of collaborative platforms and community-driven platforms, right? Why we do that is because we want to help many industries to grow more organically and more sustainably. So our team works very hard in terms of integrating different kind of technologies, right? We do the developments, and therefore then we will help industries to scale up more effectively using open and scalable technologies, lower upfront investment, and platforms that are ready to replicate. Why? Because we want to give our industry and our students the ability of integration and scalability, a modular and compatible kind of integration, ownership and active customization, and sustainable platforms for future integration. That is very, very important. Therefore, you create what we call as a maximum value creation through digital transformation ownership, sustainable technology integration, reducing your cost of overall integration, and then basically help to improve your overall rate of return or rate of investment. Okay, so right now, before I end my presentation, I would like everyone to take out your mobile phones, right? You can join a pop quiz over here. It's just a simple pop quiz for today, right? So let me share my screen over here, right? You can go to this link, joinmyquiz.com, enter the code 077127, right? And then you will straight away see, what are the quiz present there over here. Let me just show you my screen. Aha, okay. So it's a quick pop quiz, right? So you can go on your mobile phone and type joinmyquiz.com, right? If you want to win some vouchers, this is how you do it. Okay, I can see somebody just joining, right? More and more coming in. Okay, good. So click on joinmyquiz.com, key in the code 077127 over here, right? And we'll start the quiz, and I believe the one that will get the highest score will then be considered in the running to win cash vouchers of worth a certain amount that Marisa mentioned just now. Okay, all right, I'm going to give it another 1 minute for people to join in, right, before we start the quiz. Okay, how's everyone going? Okay, I have in total 1, 2, 3, 4, 5, 6, 7, 8, 9. Any more people coming in? How many participants I have today? I have 17 attendees. Okay, everyone else don't want a shot at your prizes? Anyone else joining in? You want your vouchers? If you don't want your vouchers, you can pass some to me also. I can answer all the questions correctly. Okay, anyone else? Let's give it another 1 more minute for everyone else to join in before I click the start button. Okay, already? Oh, okay, coming in more. I supposed to have, now I have 12 people here. I'm supposed to have 16 at least, right? Okay, who else is having issues? Anyone having issues joining in? You can put, you can put some feedback in the chat box if you have problems joining in. Anyone have issues?
How do I join this quiz if I'm on my phone and also listening to your talk at the same time?
Okay, you can minimize the MS Teams. You are actually still inside your MS Teams. If you go out, right, you can go to Google Chrome and key in this link, joinmyquiz.com. Yeah.
Okay, thank you.
And then you can just key in the code 077127. Okay, all in? Are we ready to go? Anyone not ready? Better shout now. You can unmute yourself and say you're not ready. Going once. Going twice. Okay, I believe all here are planning to be in the running, and we are going to start right now. Okay. Okay. Let me see. Hang on. Okay, hang on. Why is the quiz not starting? Okay, you should see the leaderboard. Let's see. All right, looking good. Okay, we have seen one person completed all. Let's see whether there's anyone else that will cut Shafiq Nasir. Two more people joining in. Any more? Okay, we're gonna give it another 10 more seconds. See if anyone else push up. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right. So I'm going to show you the top 5 winners. And there you go. These are the top 5 winners for today. I believe, I'm not sure whether it's the winners for today, but these are the points, right? And these are all, okay. Anyone else to start up? Okay.
Can you show the top 5 again? I want to take a photo.
Okay, right. This is your top 5. Okay. Done, Rachel?
Yeah.
Okay, so let's see. Let's look at the questions that you have. So let's go through some of the questions. So let's see, which of the following are part of the 4 types of data analytics, right? All these 4 are actually part of your data analytics types, right? So if you click all the checkbox, then that means you should get all correct, right? Which of the following are not part of the V's of data analytics? So therefore, the correct answer should be viability, right? It's not part of the V's of data analytics. So which of the following are not part of the 6 big losses, right? So basically, part of the 6 big losses are breakdowns, speed, startup losses, but it doesn't consider your financial losses directly, okay? How do you calculate OEE? Well, at least I'm glad to see that majority of you got it correct, right? It is your availability times performance times quality, not quantity, not speed, okay? All right, so that's basically a quick pop quiz for everyone here today. All right, so I believe that that's all for the session today. If you intend to get to know more about what we do in SHRDC, and if you would like to actually gather more information about what we do and want to hear some of our webinars, right, you can head on to our YouTube. Keep yourself updated through our Facebook and also our LinkedIn as well. Okay, and I believe some of our SHRDC team has put you in WhatsApp groups to enable better communication, right? So do get in touch with us and stay tuned for tomorrow's technical talk sessions that will be done by other of the SHRDC technical team. All right, so with that, I open the floor to any questions, right? Any questions before we end the session today?